This is going to be the second part of the math lecture where we're going to talk about accuracy and precision. I want you to be aware of the difference between those two. A lot of times in science we use terms in a technical sense that may be in everyday life. They don't have the same meaning. So something precise is something that is, the answers are close to each other. Something that's accurate is close to the right or correct value. So you can see here all of the guesses or bullseyes or darts are close together, so they're precise, and they're on the bullseye, so they're accurate. Here, in this next one, this one, they're still close together, so they're still precise, but they're all off from the correct answer. In this third example, they're all spread out. They're not close to each other, but the average is close to the correct value. And in this one, they're neither precise nor accurate. So in the last example, the last lecture we saw when you multiply or divide, you need to make sure you count your significant digits. And I'm not going to write out the word significant digit. Sometimes it's called significant digits. Sometimes it's called significant figures. I always abbreviate it this. So if you see that on a test, quiz, assignment, what that means is you haven't used the right number of significant digits. And it's usually because you've done too many. All of you should know how to round. When the value you're using to round is less than 5, you round down, keep it the same. Or if it's over 5, you round up. Now, rounding can get more complicated than that, but we don't need to worry about it. So let's take a look at how to do some of these math things so that you can do that last slide on the previous lecture on your own. And it's called unit analysis or dimensional analysis. This is a super, super important skill for you to develop. We're always going to start out with the number that's given to us in the problem. Then we're going to make sure that we include the unit we want on top and the unit that cancels diagonally on the bottom. And if you can do this when you go to college, you will be steps ahead of your other classmates. Let's take a look at doing this here. How many seconds are in one day? Well, what's the value that we're given? We're given 1 day. Okay? We know we want to cancel out days. What's the next time value, time unit, smaller than a day? Well, it's an hour. How many hours are there in 1 day? Well, there are 24 hours in 1 day. Notice what I've done here is I have a fraction, because I have something on top and the bottom, and the top equals the bottom. If the top and bottom are equal, then the value of that fraction is 1. And I can multiply anything, in this case, my starting value of days, by 1 and not change its value. Notice my days cancel out. I want to do the same thing with hours now. How many hours equals how many, what's the next time unit? 60 minutes. Again, this fraction here equals 1. Notice my hours cancel out. And now I have to go with minutes. 1 minute is how many seconds? 1 minute is 60 seconds. And my minutes cancel out, and I'm left with seconds in a day. And when you do that, you should get 86,400. How would you do this if you were asked for how many seconds are in a month, or if you look at the last slide, how many centuries are in a day. Now notice, centuries is larger than days. If I asked you how many days are in a century, you could say it's a whole bunch. Well, in this case, we should get an answer that is less than 1, because there's fewer than 1 century in a day. In fact, it's going to be like 0.00 and so on. And we could express that in scientific notation if we wanted to, or not. So I've left you with a few problems on this slide. I've left you with the last slide of the other file. All of those are in the shared classroom materials. They're the math lecture intro and the math intro practice, so that you can go back and look at them anytime you want. I hope that was valuable. Have a good day.